Okay, in this lesson we're going to review the three primary trig ratios in right triangles. The important thing to remember here is that no matter how large or small a triangle is, if the angles are the same size between those triangles, then the ratios of corresponding sides will be equal. And because of that, we give special names to those ratios, and those names are sine, cosine, and tangent. So let's see if we can jog your memory here. In the right angle triangle in your note, I have labeled this acute angle at the bottom theta, and we're asked to find the three primary trig ratios for theta. So let's remember that sine theta is defined as opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. And of course the memory tool we use to remember that is SOHCAHTOA. Okay, because sine theta is opposite over hypotenuse, SOH. Cosine theta is adjacent over hypotenuse, CAH. And tan theta is opposite over adjacent. So let's go through an example just to make sure we remember. So it says determine the three primary trig ratios for angles A and B. Okay, so let's start with angle A. If we are finding the three primary trig ratios for angle A, then we need to label the three sides with respect to angle A. Now, the side across from the right angle is always going to be the hypotenuse. That will always be the longest side, and that one we call the hypotenuse. Okay? Now, with respect to angle A, this side, side BC, is opposite from angle A. And this side here is adjacent. Okay? Adjacent is another word for beside. So the one that is beside the angle but isn't the hypotenuse is the adjacent. So, sine A would be opposite over hypotenuse, so 5 over 13. Cosine A, adjacent over hypotenuse, so 12 over 13. And tan A, opposite over adjacent, so 5 over 12. Now moving on to angle B. Let's use a different color here for B. So if I'm going to label these sides with respect to angle B, now the hypotenuse is still the hypotenuse, right? That doesn't change. But this side, side CA, becomes the opposite, and side BC becomes the adjacent. Okay, so pay attention to the fact that the opposite and adjacent depends on the way you label the opposite and adjacent depends on what angle you are labeling them with respect to. Okay, so now if we're going to find the primary trig ratios for angle B, sine B is still opposite over hypotenuse, but now the opposite side is 12 over 13. Cos B is adjacent over hypotenuse, so 5 over 13. And tan B is opposite over adjacent, so 12 over 5. Okay, so now we're going to go through some examples of using the primary trig ratios to find the lengths of missing sides, and then a couple of examples of finding a missing angle in a right triangle. Okay, so when we're solving a question like 2a, we were asked to find the length of side x right here. Okay, I would start by looking at the acute angle that's given, so the 47-degree angle, and label the side that's given, as well as the side that you're looking for, with opposite, adjacent, or hypotenuse, depending on which ones you have. So the 4 centimeter side here is adjacent to the 47-degree angle, and x is opposite from the 47-degree angle. That tells me that I need to use the tangent ratio. So we would say tan 47 degrees equals opposite over hypotenuse. Now to solve for x, we're going to multiply both sides by 4. And using your calculator, we find that x is approximately 4.3 centimeters long. Typically, we round missing side lengths to the nearest tenth and angles to the nearest whole degree, unless specified otherwise. Next question, again, looking for side x. This time, the side we're looking for is the hypotenuse of the triangle. And with respect to the angle that's given, we have the length of the opposite side given in the question. So opposite hypotenuse tells me I'm going to use the sine ratio, and we're going to write sine 70 equals opposite over hypotenuse. Now, when the quantity that you're looking for is in the denominator, okay, that makes things a little bit different than the previous example. Now, whereas in part A, we wanted to get rid of the 4 on the right-hand side, the dividing by 4, so we multiply both sides by 4. We could do the same thing here. We would just have to multiply both sides by x, because that would leave us just 8.5 on the right-hand side. And then we would want to divide both sides by sine 70. Okay, so x is 8.5 divided by sine 70, which is approximately 9 centimeters. And lastly, in part C, we are looking for the length of the adjacent, and we have the length of the hypotenuse. So this time we're going to use cosine, and we'll say cosine 55 degrees is equal to adjacent over hypotenuse. All right, this one is set up similarly to part A. So we're going to multiply both sides by 12.3. And we're going to use the calculator to determine that x is approximately 7.1 centimeters. Okay, let's look at the examples where we're actually finding the length of the missing angles. We're going to take the same approach, okay, except now we're going to label the sides with respect to the angle we're trying to figure out. So we're trying to find angle theta in both cases. So in part A, we know the length of the adjacent and we know the length of the hypotenuse. Therefore, I'm going to use the cosine ratio. And I know that cosine theta is equal to 12 over 21, adjacent over hypotenuse. Now, when you are looking for the measure of the angle, this is where you need the inverse cosine button on your calculator. The one that looks like cos to the exponent -1, except it isn't an exponent. Okay, it's the inverse cosine function. In other words, we're doing the opposite of finding the cosine of an angle. In this case, we know the angle, we know the ratio, and we're looking for the angle. Okay, so type that into your calculator, and you should get approximately 55 degrees. If you have any difficulty getting the answer correct for this one, bring your calculator to me the next time we have class, and I'll help you with it. All calculators are a little bit different in terms of their keystroke sequence. So if you bring yours to me, I will help you get it figured out. Okay. Next example, we're looking for angle theta. So with respect to angle theta, the sides labeled are the opposite and the adjacent, which tells me I'm going to use the tangent ratio. So we know that tan theta is equal to 9 over 7. Again, I need the inverse tan button this time. So theta is approximately 52 degrees. Now let's try a word problem, and then we'll be Done. So the last example says a 10-foot ladder leans against a wall. From the base of the ladder, the angle of elevation to the top of the ladder is 65 degrees. How far is the base of the ladder from the wall? I wanted to just quickly review with you angle of elevation and angle of depression. So because in this case we're talking about the angle of elevation. So recall that if this horizontal line were my line of sight, okay, it's not necessarily always the ground. Sometimes it's like from an airplane or from the base of a tower or whatever. Okay, so wherever that line of sight is, this angle above is the angle of elevation. And this angle below is the angle of depression. So if it says from the base of the ladder, that's our line of sight. Okay, so this one is actually relatively easy to set up. I'm pretty confident you could have done that without knowing what I just told you. But for some of the other word problems, I think remembering that is going to come in handy. Okay? But this example is fairly straightforward. So basically we have a wall, the ground, a ladder, sort of your standard trig question. The angle from the base of the ladder, the angle of elevation. So that would be this one. Okay, to the top of the ladder is 65 degrees. The ladder is 10 feet long, and we want to find the distance from the base of that ladder to the wall. So with respect to the given 65-degree angle, it's the adjacent I'm looking for and the hypotenuse that's given. So we're going to use cosine, and we're going to say cosine 65 degrees equals x over 10. So multiply both sides by 10. And we get an answer of approximately 4.2. So we'll say, therefore, the base of the ladder is 4.2 feet from the wall. And that concludes this lesson.